All right, so for valence and Lewis structures, you need to use the periodic table. So for example, calcium we know is in the second column. So 1, 2, right? It has 2 valence electrons. Just count over. 1, 2. So then for my drawing, I'm going to have 2 valence electrons. And remember, the first 2 go together. All right, carbon. So carbon with our special one, you may just have this memorized. It's the one where it actually separates all 4 and spreads it out, which makes carbon this like magical thing that can do all these crazy stuff if you go on to take organic chemistry. So that's carbon, hybrid. Again, we know it has 4 because as you count across, 1, 2, 3, 4. But carbon splits those top 2. All right, zinc, I actually will not ask you on the exam. So apologize if that was on there, just ignore it. Okay, so then on this side, nitrogen has 5 and fluorine has 7. Okay, and so when we think about this, because fluorine has the most, it only has 1 place to do a bond, whereas nitrogen has the least amount of valence electrons, therefore it has the most space for bonding. And so I always think about whichever one has the most ability for bonds, that's the one that's going to go in the middle. Okay, so fluorine looks like, I'm sorry, let's do it the right way, even though I know the answer in my head. So fluorine, you do 1, 2, 3, 4, 5, 6, 7. So fluorine has that 1 empty spot. So it can come in and share, right? So here, if you think about it, this is like that empty spot. And then it has the rest around it. So that made the fluorine happy, but our nitrogen still doesn't have enough. And so that's when we're going to bring in another fluorine that has an empty spot and fill it up. And then yet another fluorine that had 1 empty spot and fill it up. Okay, so hydrogen looks like that. And phosphorus, right? Looking at your periodic table, count over 1, 2, 3, 4, 5. Okay, so we come back. We're going to do 1, 2, 3, 4, 5. So phosphorus has the most ability to accept bonds. So we're going to put it in the middle. And then hydrogen has 1 to give. So it can give 1 here. It can give 1 here. And it can give 1 there. All right, magnesium and oxygen. Okay, so magnesium has 2. So again, looking at the periodic table, magnesium 1, 2, done. Okay, so magnesium 1, 2. Oxygen, you count over 1, 2, 3, 4, 5, 6. Okay, so oxygen 1, 2, 3, 4, 5, 6. So oxygen has 2 spots and magnesium has 2 to give. So what happens is, because oxygen had those 2 empty spots, the electrons from magnesium, 1 goes there and 1 goes there, okay? It kind of splits them up and spreads them out. And so then you end up with just 1 magnesium. And that's why magnesium oxide, right? Think about it. Magnesium is +2, oxygen is -2. That formula is MgO, because that exchange of those 2 electrons is a perfect exchange. They match up perfectly. So that's where this all relates, all these charges and these Lewis structures. So there we go.